Okay.
Yes.
Okay, that's fine. So this first session we're going to um look at qualitative, qualitative analysis. So for the preparation for your exams, of course, you have three questions to answer. You have three questions to answer. You have the question one, which is qualitative analysis. You have question two, which is quantitative analysis. Question one, quantitative. Question two, qualitative, and of course, the question three will be general, paper. It's going to ask you questions on your general knowledge of chemistry. Okay, so for this session one, we are going to try to focus on question one, which is your quantitative analysis. Okay, so I'm going to take you through a few background in that. I will share my screen now. Okay, I want you to ask questions in areas that you do not understand. Ask questions, please. Don't keep quiet. Ask questions, and if you can see my screen, just wave to me. I will know that you can see my screen. Okay, that's fine. That's fine. Okay, so for this qualitative analysis is basically our focus for the lesson will be number one. We're going to review the basic rules for acid and base titration. You can jot down, but don't worry, I will send you materials. Okay, I will send this material to you. Okay, and I also have recorded videos that I made that will assist you to do your private study. Okay, so we're going to be reviewing basic rules for acid-base titration, and we're going to see how you can correctly fill titration table of results, which is very important, how to fill the table of results for your titration. We're also going to look at how to fill your burette and acid with acid, and your pipette with what? With base. Then how to carry out titration, how to find average titer value, and the ultimate there will be how to perform quantitative calculations. Those calculations, that is where the bulk of the marks will be. That's where the bulk of the marks will be doing your calculations. So I have put together some questions that will that if you go through them very well, I can assure you that your exam will be a walk in the park. Okay, so I will take you through those calculations step by step, how to calculate them. Okay, good. So basically, of course, you know that titration, okay, has to do with the slow addition of one solution, okay, of a known concentration. When you say a solution of a known concentration, let's assume that this is a solution. Okay, I know the concentration of this particular solution. Okay, to know the concentration means I know the amount in moles of solute dissolved in this. Good. So if I know the known concentration, then I have another solution, but I don't know the concentration of the other solution. So what do? I take that other solution, okay, then I titrate the first solution with it. So by titration, I can tell what this particular solution is, so that I will use the volume of the acid, for example, okay, with the volume of the base. I know the concentration of the acid, but I don't know the concentration of the base. So out of four things now, usually we know three things: concentration of either acid or base. Then you know the volume of what? Base. By you use your pipette to measure the volume of base. So the volume of base is already known. So essentially, this is what I'm saying, that in doing titration, we'll talk about in doing titration, we'll talk about having known concentration and unknown concentration. So when you say known, basically we'll have acid, okay? We have your acid, okay, and you have your base. You have acid and base. So usually you know the concentration. You need concentration of acid. Okay, you also need to know the concentration of base. You need the volume of acid. You also need to know the volume of base. So out of these four things, usually your pipette will give you volume of base. You know, you use the pipette to take some quantity of what? Of base. The Bible will tell you the volume of base. Then the concentration of base may be told, and it may not be told. The concentration of acid may be told, and it may not be told. But essentially, you use your buret to know the volume of what? The volume of acid. Okay? So you use your buret to know the volume of what? The volume of. So now, out of these four things, each time three things will be known. Then you will use your formula to find the third thing. That is what we call standardization. And that is what titration helps us to do. So you are adding something that you know into something that you don't know, so that you can walk from behind to find the one that you don't know. Okay, so that is the meaning of titration. And basically you'll be working with acid-based titration, meaning that you'll be using your acid to neutralize the base. Okay, using your acid to neutralize the base. And of course, by now you should know about your what do you call it, neutralization reaction. Okay, do you want to tell me what neutralization reaction is? Anyone want to tell me what you think neutralization reaction is? Yes. Your audio is not loud. Okay. Or you can type in the chat room. I can read it out. Okay. Yeah. And those of you joining us in the YouTube private link, you can send your chat into, okay, on the YouTube private link. I can read it out. Okay. Good. So now let's look at, let's now start. Okay, proper. So let's start proper. Now, for the first thing you need to know will be checking your setup. Checking your setup. Setup means that when you get to the laboratory, okay, they will put some things on your table to write your exam. And not to make mistakes, you must ensure that your what? That your setup is you must ensure that your setup, every material that you need for your work is on your table. That is what we mean by what? By setup. Make sure that all the materials that you need for your experiment is on your table. That is the meaning of what? Of setup. Okay, good. So let's see how we can do our checkup for setup. Okay, I'll show you the work in the real laboratory where I set up the table for this particular experiment. Okay, and I will now explain to you. Okay, so I will just show you the video of the setup quickly. Okay, and I need to listen. If you are not hearing me, let me know you are not hearing me. Then I will explain over what the setup is. Okay.
This is chemistry practical class, and for now we're going to look at quantitative analysis.
Okay, can you hear it well?
Yes, sir.
Okay, that's fine.
So basically this is a setup for titration. Okay, so for titration you use a known quantity to find an unknown quantity. So this setup is basically acid and base titration setup. Okay, so you have acid in the 250 cm3 beaker, and you have your base in another 250 cm3 beaker. Of course, you have the funnel for pouring your acid into the burette. You also have the pipette, okay, for taking certain quantity of your base into the conical flask. Okay, so your conical flask will house or host your base. Okay, this is the base. So the conical flask will host the base. Your burettes normally host the acid. Okay, so that is the acid-base titration setup. And of course here I have the indicator. Okay, so I'm going to be using this glass rod as my pipette for now. Okay, your pastor's pipette. So I'm going to be using this for dropping my indicator.
Okay, so you can see the materials that you need. You need your beaker, you need your pipette, you need your burette, you need your indicator dropper. Okay, so when they set the table for you, before you start your experiment, make sure you check that you have everything that you need. Okay, things that you need, quickly let your teacher or the laboratory person know, so that when you are doing your work, there will not be delay for you, because usually you don't have enough time to work. So most students don't get the things they need on their table, maybe because it was omitted, and you will not be able to finish because they were waiting for materials to be brought to them. So check your table. You will need your conical flask. Usually you need a minimum of 3 conical flasks. You need a beaker, you need a burette, okay, you need a pipette, and you need your indicator indicator dropper. Then you also need your tie. Okay, a tie is just a white background that will help you to be able to see your color change properly. Okay, good. It will help you to see your color change properly. Now let's look at how do you handle titration apparatus. How do you handle titration apparatus? Okay, so I want to take you through these rudiments. They will now go into your calculation, which is very, very important. So how do you handle laboratory apparatus? Okay, so I will explain quickly to you how to handle your burette and your pipette. So I need you to listen to these two carefully.
About the management of this setup, how do you keep your purity level so that you can have accurate title value? So it's important that you know about your burette. Your burette will house your acid. Okay, so what you need to do is, after rinsing the burette with water, the last liquid that must be used to rinse your burette must be the
Sorry.
About the management of this setup, how do you keep your purity level so that you can have accurate title value? So it's important that you know about your burette. Your burette will house your acid. Okay, so what you need to do is, after rinsing the burette with water, the last liquid that must be used to rinse your burette must be the liquid that the burette will hold. Okay, so after rinsing this with water, you can see, rinsing this particular apparatus with water, I have droplets of water inside. So if I want to start my experiment and I decide to pour my acid into this directly, it's going to affect the concentration of the acid because I already have water droplets inside. So what you do is, you have to rinse this particular burette with the acid that the burette is to hold. So, okay, you can use your funnel or you use your beaker directly like that. So I've added it. Okay, so the rule is, rinse your burette with the liquid the burette is to hold. That will be the last liquid you use to rinse your burette. Okay, and the reason we are doing that is not to over dilute the solution. Okay, that's the reason, so that you will not over dilute your solution. Under your question 3, they ask questions on the management of apparatus. So that's the reason why you rinse your burette with the acid, because the acid is the solution that the burette will have to hold. Okay, so that's it. Then apart from rinsing the burette too, okay, we'll talk about this conical flask. The conical flask also hold your base. Okay, but just opposite of this, you do not rinse your conical flask with base. Okay, you rinse your conical flask with distilled water. Rinse it with distilled water. Okay, so if you go ahead to rinse this with base, okay, rinse this with base, and I have droplet of base here, and I'm to use my pipette to take 25 mil. By the time I add 25 mil, I'll be having more than 25 inside. So that is why tighter value differ. So you need to know first how to manage the apparatus. So you rinse your conical flask with what? With distilled water and distilled water only. Even if I have distilled water inside this particular conical flask, okay, to this half level, and I continue my titration, it doesn't affect my titration because the concentration of base, I mean, the amount in moles of base is still remains the same. Okay, so rinse your conical flask with water, while you rinse your buret with what? With acid. Okay, that's about management of your apparatus.
Okay. So you've seen how to handle your buret and how to handle the pipette, how to handle the conical flask. Is very important because if your buret is dirty and your conical flask is dirty, or you have water droplets in your buret, it's going to dilute your solution, and the result you'll be getting will be different from the result of your colleagues and your exam center. The truth about WAEC and titration is that every school will have a different title value. Okay, your title value should be the same within your school. Okay, because your teacher will do a certain title value that they will send to WAEC, and it is that title value that they will use to compare with your own results. Please, it's very important that you are as accurate as what as possible. Okay, very important that you are as accurate as what as possible. Okay, so now I want to be sure that you pick one or two things from that explanation. Okay, so who can quickly tell me? You can chat in the chat session, just put it there. Who can quickly tell me how uh to make sure that your buret is clean, and if your audio is okay, you can speak. Okay, from the YouTube private page too, you can send in your responses. Yes, please. Yeah, we want to explain to us. Yes, Sean or Yusuf, who want to explain to us.
The video said that you should rinse it with the liquid that is being titrated in the burette.
Okay, so and what is that liquid? What is that liquid?
The acid.
The acid. Okay, the
Yes.
acid. And your conical flask should be rinsed with what? With distilled water. Okay. Yeah. Yeah. After I'm talking about after washing, rinsing, then the last liquid you use to rinse your bureau to be the acid. The last liquid to rinse your conical flask will be the what? Will be the base or the alkaline that it's so to hold. Okay. So let's look at a few what do you call it, a few rules that can help you along the line quickly. A few rules. Okay, so Mama, the first check that you need to do, like I said earlier, check your table. Okay, and I've also shown you real life practical laboratory. Check your table that you have everything that you want, that you need. It's very important. Okay, usually your teacher will explain, will talk you through the checking of your table before the exam starts, because it's very important that you have everything. So if you can see this particular setup, I have the conical flask. Okay, I have the conical flask there. And apart from the conical flask there, what else can you see? Okay, this is the conical flask. I have the conical flask. I have the beaker. Okay, then I have my buret. You can see I have the buret there. That's the buret. This is the buret. I have my clamp. Okay, yes. So these are the basic materials that is what that are required for your titration. So make sure you check that. Okay, then number two, rinse your buret. Rinse your buret. Okay, after washing your buret, make sure you rinse your buret lastly with what? With acid. Okay, ensure that it is very clean, especially if the exam center you want to use, they are doing the exam in batches. So if the first people are finished and the second batch are coming inside to use the same apparatus, then those people who are in the second or third group need to be very careful. You need to wash your apparatus well. Okay, and rinse your buret with what? With acid. That will be your guide 2. Okay, and guide number three will be rinsing your what? Your conical flask. Rinse your conical flask very well with distilled water. Okay, never rinse your conical flask with the liquid it is to hold. The conical flask will hold acid, I mean base. Never rinse the conical flask with what? With base, at least as the last what step. Okay. Then the next thing will be filling your buret. This is very important. Another important step to fill your buret. Okay, make sure you fill your buret using the beaker or using your funnel. The best is using the what? Using the funnel. And in filling your buret, you fill your buret to the mark called the 0 centimeter mark or the 0 mil mark. I will show you very soon how to fill your buret practically. Okay, so you fill your buret to the 0 mark. So why the 0 mark is usually somewhere, at the top there. Okay, usually somewhere at the top. So when you are filling, make sure you fill your buret to that what? To that point. So use your beaker. Beaker has a tip at the mouth. The mouth of the beaker is something like this, so the liquid can come directly, or you can use your funnel. Your funnel is the best practice. Use your funnel to actually pour your liquid into the what? Into the buret. Okay. Then when you have done that, the next thing, of course, will be to secure your buret. That means make sure your buret is tightly, on the clamp, and make sure it is straight. Okay, don't let your buret be bent. Don't let it be bent like this. Make sure your buret is what? Your buret is straight. Okay, to give you accurate reading on the buret. Okay, then I've talked about rinsing your conical flask. It's very important. Rinse your conical flask very well. Okay, never rinse it with what? With the liquid it is to hold. Okay, now how do you, okay, add your what do you call it, your base into the conical flask? You use your pipette. Okay, you use your pipette to suck certain quantity of your base and put it into the conical flask. I will show you also what to do. Okay, so after that, the next thing will be to add your indicator. You add your indicator to your what? To your base, to the liquid in the conical flask. So by now you should go and recall the various color change. Okay, the various color change. Okay, so you guys usually use methyl orange or phyllophthalein, but this year you are going to be using methyl orange. Okay, so just focus on that. Methyl orange changes from know the color of methyl orange in base and the color of methyl orange in what? In acid. Okay, in acid your methyl orange is red, while in base your methyl orange is what? Is yellow. So when you add the indicator into your base, you get a yellow what? A yellow color. And the way to get a yellow color, after some time titrating, the yellow color will change to what? Will change to red. Okay, that's how you know that you have reached what? Endpoint. Okay, not deep red. When it gets to deep red, it means that you have crossed your endpoint, neutralization point. Okay, and you are moving on to what? Onto the acid what? Acid region. Okay, just something slight. The color is changing to like from yellow to orange, tending towards red. That's when you stop your what? You stop your titration. So at that point you say you have reached your what? Your end point. Okay, now let me tell you something about reading in the buret. Now, reading in the buret, you must have heard about the word meniscus. Okay, so when a liquid is in a container, when liquid is in a container, the liquid will form two meniscus, upper meniscus and lower meniscus. So if you look at this particular burette now, I have the lower word, the lower meniscus here. That is where my arrow is showing. That's your lower word meniscus. Or that is what you read. If you look at the top here, I have another level. Okay, another level of liquid at this point. You don't read this particular level. If you read this particular level, you'll be getting a volume that is lower. Okay, a volume that is lower than what it actually is. If you look at this particular reading, this reading is actually here. Can you see that it's actually here? Can you see my arrow, my line that I'm drawing? It's actually there. So that is what we call the lower what? The lower meniscus. Meniscus is when your liquid forms something like this in a container. That is your meniscus. So you read the lower what? The lower meniscus. Okay. So how do you read the lower meniscus? Make sure your eye is parallel to your buret. Okay. I'm just explaining background now. We'll show you in the laboratory as I'm actually filling the buret and measuring the buret. Okay, so this is essentially what I'm saying. Okay, this you can see your meniscus. This is your lower meniscus. Okay, can you see that? Some liquid form this, water form this kind of meniscus, downward meniscus in a container. Why liquid like mercury form this kind of meniscus in a container. So you are going to be dealing with this particular type A. So your buret will give you this kind of value. So if you look at this, for you to get your accurate result, your eye must be at the level, must be parallel to your words, to your buret. Okay, so can you see? If you are watching your buret trying to read, must be parallel to the level of the liquid. If it's shorter than you, then this is the reading you'll be getting, and this will be a wrong word. It will be a wrong reading. This will be a wrong reading. Okay, this is accurate. So don't put your buret somewhere and be looking at it at the top like this. You get a wrong result. Don't look at it down. Some students will put the apparatus on the stool. Okay, you get a wrong result. Make sure it's always parallel to your eye. Make sure it's parallel to your words, to your eye. That is going to get accurate word, accurate result. Okay, good. Now, so the next thing will be, how do you record your readings? Recording your readings, very important also. Now, this is where your marking starts. Where they are marking your script, this is where you start. So you must do this table on your question or your answer sheet. Okay, you write first the volume of pipette used. Volume of pipette used, you are using 25 cm cube. Okay, you write it there. Then indicator use. Indicator use, you are going to be using metal orange. Okay, good. You are going to be using metal what? Metal orange. So you write metal orange. Then you now do your table. I'm sure you can see my own table. Okay, you do your table. Let me make it bigger so you can see properly. You do your table like this. Okay, you do your table. This table, you have this particular column, buret reading, and you have final reading, initial reading, and volume of acid used here. Okay, so you write all that around here. Then you put your units there. Okay, also you need to know in your unit that 1 mil, okay, is equal to 1 cm cube. So if the container you have they wrote it as mil, okay, it doesn't matter if it is mil that they wrote it as mil. It really doesn't matter. 1 mil, okay, actually has the same value as what? As 1 cm what? 1 cm cube. Okay, so that is what you have here. Then the first thing you do is, you have poured your base in your acid into the buret. The first level where you are starting from is called what? The initial level. Initial level. And usually you start from 0.00. Okay, so when you now allowed your acid to pour through your buret into the conical flask, you are using the acid will get to a particular a particular level. That means you have run the acid into the what? Into the conical flask. Okay, when you have run the acid into the conical flask, let me show you this. If you look at this particular buret that I have here, let's assume that I started from this 0 level. Okay, your buret is actually 0, 0. Now, when I've run the acid into the conical flask, the level will reduce. This will be like my new level now. Okay, this is my new level. So at this new level, I will take my reading, then I will record it into there. So let's assume it is 26. Then that will be my word, my final. So the volume of acid used now will be 26 minus 0. And that will give me what? 26. That is for the rough word, the rough titer. Okay, so we'll repeat the procedure for first, second, and what? And third. Okay, good. You understand that better when I show you the live application now. Okay, I've also explained to you about your color change. Okay, so one thing that I need to explain now is endpoint. What is endpoint? And they normally ask this question under question 3. Okay, question 3, they will ask what is endpoint. Okay, good. So are you guys still with me?
Yes.
Okay, good. So what is endpoint? Endpoint is a neutralization point. It is a point at which all the volume of acid has neutralized the base. Your end point, okay, your end point is a neutralization point, a neutralization point where all the moles of acid present has neutralized the what? Has neutralized the base. Okay? It's the point where all the moles of acid present as what? Neutralize the base. That is your end point. Okay? End point is usually different from equivalent point. They normally ask in WAEC for you to differentiate that. What's the difference between end point and what? And equivalent point. I said end point is the point you get practically when all the acid has what? Neutralize the base. Okay, but your equivalent point is calculated. You do it theoretically based on the equation of reaction. So the equivalent point tells us a particular volume of acid that will neutralize the base by calculation. That means by prediction. That's the right word. So equivalent point is by prediction, while end point is by actual titration. Okay, so now when you do at your end point, the volume of acid that you get in your burette used is called your titer your titer value. Okay, good. So let me show you quickly your color change that you need to observe. Okay, these are the color change you need to observe. See, your metal orange, your indicator usually, okay, will give you yellow. Okay, your indicator metal orange is yellow in alkaline. It's also yellow when it's neutral. Okay, the moment you are titrating and the color changes to what? To red, that means that you have moved away from neutralization point. So you quickly stop adding adding acid. You quickly stop adding acid. Very important for you to identify this particular change, because if you are adding your acid to a container containing a base, what do you think will happen to the pH? Will the pH be reducing or will the pH be increasing? Yes, you can answer. I'll mute yourself and answer. If I'm adding acid to a base, what will happen to pH? Will pH be reducing or increasing? Yes, who want to answer?
Reducing.
Okay, pH will be reducing. That's fantastic. pH will be reducing. So this is where we start from. As we are going this way, we are going to acid. Okay, pH will be reducing. Of course, you know that neutralization point is 7, neutral pH is 7. If it is strongly alkaline, you have 14, right? If it's strongly acidic, you have what? 1. Okay, so if you are going this way, direction of this arrow, then the pH will be reducing. That's fantastic. Okay, so you need to identify the color change. So when you are doing your titration, please look at this very well. When you are doing your titration, okay, you start with if this is metal, this is how phenolphthalein will look like anyway. Okay, so when you are doing your titration, you can see this picture, the middle one. When you are adding your acid to it, to the base in the conical flask, you can see a slight, look and say I'm having a slight change. When you swirl it, then that change will go again. It will go away. That means at that point, you need to now be added drop wisely, because you are almost getting towards to neutralization point. You're almost getting to neutralization point when you begin to see something like this. Then at the end of the day, you are going to end with what? With this. This is your end point, because you have seen a color change. Now, make sure you don't make yet your end point, your color change, be so red. Okay, when it is so red, then it means that the volume of acid you get is too much, it's in excess. Okay, don't make sure it is as red as this. Okay, just slight color change, make you get something like this is fine. Then you stop your what? You stop your titration. Okay, so now let me show you guys how to fill the burettes practically. How to fill the burettes practically. So let me show you in the lab. So just watch attentively. Then you can ask me questions on anything you don't understand. Okay.
Your acid into the burette. The burette has a maximum value of 50 mil or 50 cm3. So pour your acid into the burette, but you must ensure that your apparatus is not leaking. So you must have checked your jets properly. Okay, so this is intact. Then you pour your acid into the burette. Okay, that way using your beaker if your hand is very steady, or best practice you can use your funnel. Okay, so I'm putting my funnel in. Okay, so that way while you do that, you have to watch this particular jet whether the liquid is not coming out. So I've checked this and I've assured that my acid is not pouring away, so I can go ahead to pour my acid into the burette. So try as much as possible to be fast and accurate, because you are working with time in an exam. It's not just a demo, you are working with time in an exam, so you need to try as much to be fast. So now I've poured my acid using my funnel. One of the disadvantages of using the funnel is that most students forget to remove the funnel after they are taking their measurement. If you don't remove your funnel, because no matter how, you see how liquid inside your funnel, and while you are doing your titration, they will keep dropping and it's going to be affecting the volume that you have. So you want to pour your acid, make sure you remove the funnel. Okay, so but if I look at this level, the level is not at the level of the zero mean mark. So I want to ensure it's at the level of 0 mean mark. Okay, so I need to pour out a little bit from here. Okay, but usually I do not want to pour back into my acid because I'll be contaminating this. So I'll just take this. If you have an extra beaker, get an extra beaker to collect that, or you just take a little that away. So you check the level. Okay, so let me use an extra beaker as my wash beaker. Thank you. So I've got an extra beaker as my wash beaker. So I want to pour that out of this. While you do that, make sure your eye is parallel to the level of the lower meniscus. So I'm doing that, and the level is coming out. Just open your tab. Open your tab. Okay. So I've got it to that level. Yeah. Good. Okay. So yeah. So let's move closer so that we can see. You can see the level of the meniscus here. So let's zoom closer so that you can see the level of the meniscus. Okay. So here I'm starting at 0. That is the initial level of my acid. Very important. Initial level of my acid. So in your record book, which you can see on the screen, you have your initial, you have your final, okay, measurement of acid. So you record 0 on the initial level, 0, okay, as the initial level of your acid. Good. When your acid is set, then the next thing will be to take your conical flask, okay, take your conical flask and pour in your base into the conical flask. Pour in your base into the conical flask. So what do you use to measure your base? You use a pipette. Okay, so this is my solution B, which contains the alkaline. This is solution B, which contains the alkaline. So you have to be to ensure that you look at the label properly so that you don't make mistakes. Okay, so I will dip my pipette into the alkaline solution. Now, what are the rules in using this pipette working with this? So if I dip this pipette into the alkaline solution, don't let your pipette touch the bottom of your beaker. If it touches the bottom of your beaker and you're trying to use suction pressure to take your alkaline, it's going to form bubbles. Okay, so make sure it's at the middle. just at the middle. It's not touching the bottom. Okay, that's very good, just for your personal safety. So I want to measure 25 ml of my alkaline. So I take 25 ml. Okay, you can see the way my hand is set. Okay, so when you are taking 25 ml, how do you know you have measured exactly 25 ml? On every pipette, there is usually a mark there. That tiny mark tells you that from the tip here to that particular mark is 25 ml. Okay, so while you are holding that, you can see this level is going down. If I release my hand, okay, it keeps pouring into the solution. If I put my hands tightly on this, it's going to stop. Okay, so I'm going to stop it again and let it get to that 25 ml mark. Okay, so you release your hands gradually. Gradually, you have to be as accurate as possible. I'm releasing my hands gradually now. Okay, until I get to that 25 ml mark. Okay, some prefer to use their tongue, whichever one works for you is fine. Okay, so I'm taking my lower meniscus, so ensure that the level of the meniscus is parallel to your eye. That's the best way to get the accurate result. If you raise it higher like this, okay, you get a wrong result. If you bring it lower, you get a wrong result. So make sure it's parallel. Now I have my base at that particular mark. So I'm going to pour it into my conical flask. Okay, so I release that into my conical flask. Okay, don't bother to push it out because of time, because you might be contaminating that. And when you are done with that, okay, don't blow the last that you have tip there into it. You don't need to blow. You just let it drop by itself. The best you can do is to dip it inside and let it touch it. It takes the last drop off. Don't blow it into that. So now I have 25 ml of my water, of my base, and I have my acid set for titration. Okay, so the next thing we want to go into will be titrating to get the value of acid that will neutralize the base.
Okay, so the next thing we want to look at is how to titrate the volume of acid against the volume of base. Okay, so you have done your setup, you have filled your burette, and you have filled your your conical flask with the acid, and your conical flask with the burette with acid, and your conical flask with with base. Okay, so the next thing basically would be adding your indicator. How do you add indicator? Okay, so depending on the setup in your school that is provided for you, how to add indicator. So I need you to watch this laboratory demonstration to how to add
your
indicator.
metal orange indicator. So usually for your titration, you just need a few drops of the indicator, like 3 or maximum 4 drops of the indicator. So use your pastor's pipette. Don't attempt to pour your indicator like this, no matter how much in pouring you are. Just use your glass rod like this, or you use a pastor's pipette. So if I'm using a glass rod, you can say I dip the glass rod into that. Okay, I wait a bit. Can you see the drop is going to come and go into the solution of your base? So just, this is a drop. Something like this is a drop. Whether it's coming from the rod or it's coming from your pipette, that's a drop. Okay, the quantity of indicator you use can actually affect your titration. So if you use the indicator too much, you may not be able to determine your end point. Okay, so it's important that you follow the rules. 3 or maximum 4 drops of indicator will be fine. Okay.
Okay, so in adding your indicator, follow that rule. If you use too much indicator, then it's going to interfere with your what, with your end point. You'll not be able to determine the actual what, the actual color change that you need to see, and to know when exactly you need to what, to stop your titration. Very important. 2 to 3 drops of what, of indicator. Now we are getting almost there, and that is doing the rough what, titration. Doing your rough titration. This is like the main thing. You meant to get your rough titration wrong, then you may not be able to maximize your what, your time that you need to do all your titration. So how do you do rough titration? When we talk about rough titration, if you look at the table that I showed you earlier, the table of result, this table of result, okay, you can see here I have rough. Okay, let me make it a bit bigger so you can see that I have rough in table of results. Can you see the table of results? I have rough. The rough means that I just want to pour my acid into the what, the base, without actually minding the volume. So when you are doing your rough, your focus is on the color change. So rough means it's going to give you a rough idea of your title word value. That is what rough is. It's going to give you a rough idea of your title word value. Okay, so I'll show you how to do rough. Okay, carry out your rough and how to record your rough value. Okay, be noting down all the questions that you want to ask me. Okay, before we now go into calculations. Okay, it's very important that you get your title value very well. Okay,
So now we want to titrate the acid against the base. Okay, but there's something else that we need to do. To titrate the acid against the base, we need something to tell us when to stop titrating the acid, when to stop pouring the acid into the base. And that particular substance is called the indicator. So what does it indicate? By color change, it indicates the point at which the quantity of acid added has completely neutralized the base. So that simply means that your neutralization has been achieved, and that point we'll call it the end point. So that means that's the point where you're going to stop pouring your acid into the base, and whatever volume of acid that you got, it will be called your titer value. Okay, so now let's take our indicator and pour it into the base. Like I said earlier, take 3 or 4 drops of indicator maximum. So I'm going to take this. Okay, that will be a drop. That's 1 drop. Okay, I'm taking another one. That's my 2nd drop. Okay, I'm taking another one. That's my 3rd drop. Okay, let's make it 4. That's all. Okay, so you have your indicator, drop into that. So you can shake this. It's very important that you are able to observe color change. So you can see this. Okay, so I have this this color here. So measuring it against your tile background, you'll be able to see the color properly. Okay, so this looks somewhat like yellow. Okay, you can see like light yellow. So we are going to be observing color change. Now this is called the first titration. The first titration. Okay. Now for your first titration, usually it is known as rough value, meaning that you don't have an idea of where it's going to stop because you've not done any. So you can just be as rough as possible. That means you want to pour your acid into the base quickly. So now I want to pour my acid into base. So when I'm doing my rough, the focus of my eye will not be here. My eye will be focused on observing the color change. Okay, so I'm focusing on this. I'm using my hand to do a swirl of the solution. That is just to affect the rate of reaction, and I'm using my other hand to open my tap so that the acid can keep pouring. Okay, so let's go and do that. So I'm pouring my acid now, okay, into the base, and I'm swirling, okay, just like the form of stirring. why my acid keeps dropping. Don't bother about the level of the acid in the burette. Okay, to take care of itself, you just focus on the color change. So I'm pouring it very fast and in form of jets. Okay, so while you are pouring that, you will notice that at the middle, it looks as if there is a color change that wants to come. That's an indication that you are almost getting to your end point. So you may decide to just now go and do drop wisely. That means you are not pouring it slowly, so that you can be as accurate as possible. But don't forget, keep your eye on the color change. The color change here is going to change from my yellow to a color that you are going to see very soon. Okay, go, keep stirring. We are almost there. Okay, yeah, let's zoom closer. Okay, good. Can you see that? That's a brilliant color change. It's easy to recognize that. So at this point that we have this color change, that indicator has done its job to tell us that at this point is your end point. End point means you have to stop your titration. So the next thing you are going to do now is to quickly take, you can see how I'm manipulating this apparatus, okay, so that it should be at the level of my eye. Okay, you do not put this on the stool and be measuring it like this, you get a wrong result. Okay, or neither will you be looking at it from at the top. If the level is taller than you, then you can always manipulate this to your level. So really there is no disadvantage in terms of height, really. Okay, so I'm measuring this value now, that is 26. Okay, 26. So zooming this to that level, you can see 26. It's very important that you take the lower meniscus. So if you have problems seeing that, you can use your time to just put it, you'll be able to see it properly. Okay, so using my time to do that, I can see I'm at 26. Yeah, exactly 26.0. So this will be my final measurement, 26.0. I started from 0 and we pour the acid into the base until we get to 26. So that is 26.0 is my final for my rough titer. Okay, go. So the next thing we'll do now will be to look at how to do the first titer. Okay.
Okay. So I want to believe that you've got one or two tips so far. Okay. So yes, I want someone to quickly tell me what you gained so far from this, or what you have been able to recall on doing your first titration, especially how to record in the table of results. Yes, want to tell us something on that? Professor Akonde, you're welcome, sir. Okay, so want to say something on that quickly, on what you gain on carrying out your first titration and recording in the table of result, what you got. I mean, carrying out your rough and recording in the table of result. Okay, anyone quickly? I'm sure I'm audible enough, right? Can you hear me? Can you hear me? Okay, so can you tell me what something that you learned in carrying out your rough titration? Something that you learned, how to do the rough. Do you understand how to do rough titration now? Yeah. If your audio is not okay, you can use the chat room to actually send me, to chat, to send me a message so that I can read your message out. Okay. So can we proceed? Can we proceed?
Yeah.
Okay. Okay. So in doing your rough titration, like I said, you need to just focus on the on adding your acid to your what, to your base. Okay. Focus on the color change. When the color changes, then you can actually stop. Then you now note the volume of what, of acid used. Then recording in the table of result is very important. Okay, recording in the table of result, I think that is very explanatory. Okay, so let's move on to after your rough, the next will be to do your what, your first titration. Okay, carrying out your first titration. Your first titration means now you want to do the first accurate, titration. You now want to be more careful in doing your what, your titration. That is the meaning of this particular first titration. In the rough that we did now, we got 26 cmq, 26 mil or cmq. I told you earlier that 1 mil is same thing as 1 cmq, so we are able to get 26 mil. Now, to do the rough titration, the first titration, your initial level, okay, would have to change. Your initial level in recording, this is what you recorded when you did your rough titration. You got a recording like this. So if you want to do your first titration, you need to have your initial level. You need to have something here as your initial. Okay, so I need to quickly explain something here. If you look at this particular buret, your buret start from 0 and it ended at what? At 50. So when you are adding your volume of acid, the level will be decreasing like this. It will be going down, it will be going down. So if I assume I stopped at 26, my first titration here, I use 26. Now, if I do 26 plus 26, 26 plus 26 will give me 52, right? And 52 is more than the volume of what? The volume of the buret. The total volume of buret is 50. This buret from this 0, okay, to this level is 50. So it means that if I do not fill my buret again, okay, based on my rough, if I do not fill my buret again, I will not have enough volume of acid in the buret to titrate against the base. So that means I need to add more because I stop at 26. So I need to add more acid to my what? To my buret. So when you add more acid to your buret, it will give the advantage of having more than 26, okay, level to use for your first word titration. So in the video, I'm going to be showing you, I'm going to be adding more so that you understand the reason why I am adding more what? More volume of what? Of acid after my rough what? Titration. Okay, so let's move on that.
Now let's do our first title. After the rough title, you can see that we're focusing on looking at the color change, and we're not bothered about how the acid was actually dropping to a new volume in the buret. So to do your second title or the first title after your rough, take another beaker, a fresh beaker, okay, because in the exam you won't have time to be rinsed. You just take another beaker, then measure your base as we did initially. So I'm measuring my base, which you can see I'm almost making a mistake there. Okay, pour your base into the conical flask, not the acids. Okay, so now I'm going to take my base and take 25 ml of my base quickly. Okay, so I take 25 ml of my base. I release my hand so that the level can drop. When it gets to 25 ml exactly, then you drop that and take your conical flask and pour it into the conical flask. So you are going to repeat the procedure for the rough, for the first, for the second, and for the third title value. Okay. So having done that, the next thing will be what? To add what? Indicator. So now to add indicator, don't forget the rule 3 or 4 volume or drops of indicator maximum. So if you started with 3 for the rough, you have to do 3 for every other one. You started with 4, you have to do 4. So I have to make sure my 4 is complete. The essence is to make your experiment a fair test, so that it will look as if you have the first and not the last. So I have my indicator in the base, so then I have my acid here. So I need to ask myself question. When I did my rough, I stopped at 26. So definitely, if it is rough and I want to do my first one where I need to be more accurate, so it means that my value will be around that 25, 25.5 or 26. Okay, so that is a guide. Now, if I did the first one, I got 26, and the maximum value of my buret is 50, it means that to get another 26, that will be 26 plus 26 will be 52, which is more than this value. So therefore, I need to add more what? More acid to my buret. But let's assume after doing the rough, I got 10. So I don't need to add more acid, because I can still get as many more 10 from my buret. So now I want to add more acid, okay, to my buret. So you can add more acid to your buret, just add it to 0. You can add it back to 0, which is just as good as it can be. Add it to 0 or add it to 10, stop at 10, okay, as long as you can get 26 more. So I prefer to add it to 0, so that I can know I'm starting from 0 each time. Okay, so I'll take this back to 0. Okay, so don't forget the rules with using the funnel. Remove your funnel from your what? Remove your funnel from your buret. Okay, so the reason why you have to remove your funnel from your buret is so that you can get accurate results. The value will not keep dropping. So looking at this, I have it's slightly higher than 0, so I want to just drop a bit into my wash beaker. Okay, so I'm dropping that. Good. Now I have my lower meniscus at 0. Good. So now let's take this conical flask, my first titer. So I'll do that. My first titer now. Now I want to do my first titer. The reason why we call it first titer means it's your first most accurate titer. First most accurate titer. So I put my hands here, then your eye now focuses on this, no longer this. Okay, you now focus on this because you are now concerned about the accuracy. If my first titer was 26, my first titer was 26, therefore I can be very fast and run it from 0 to 20 to save time, because you need to work with time as you are working in your exam. Okay, so I want to focus on this now. First titer is 26, so my second titer should be around 20 something. So I can pour this very fast into that. So I'm focusing on, I'm looking at this until I get to what? To 20. Until I get to 20. Okay, so don't bother about this. You can keep shaking. Your eyes should be focused on this. Okay, so it will not change because we got 26 earlier. Now I'm around 20. So I now want to stop. The reason why you do that first is to save your time. So you don't start from 0 and be doing drop wisely. So before you know, they will ask you to submit and you won't have done anything. So just rush it from 0 to 20. It will never change because you already recorded 26. So when you go to 20, you can now start adding it step wisely or drop wisely if you like. Okay, some could be as confident as running it to like 23. Okay, very fast. So I'm dropping it now, drop wisely. So at this point, your eye will no longer be here. Your eye will now be focusing on this because you now want to see the color change. So if you zoom it, you'll see a color change at the point at which the drop is touching the solution. Okay, so I'm focusing on that as against the time. So you look through against the time. So focus on this, you shake, keep shaking, keep shaking, keep shaking. Okay, so at a particular point, just one more drop will change your solution. So you have to be as careful at this point as possible. You can see I'm doing it just one drop at a time. One drop at a time, then you shake. One drop at a time. Can you see the change? Right? Okay, so I have a color change. Can you see the color change? So now we need to check the value that we got. Okay, so read your value, read the lower meniscus. Okay, now I got 25.5. Okay, so you record your 25.5 as your final. So record the initial is 0. So now we have 25.5. Okay, so usually for your exam, your difference should not be more than 0.1, 0.2. Okay, so but the rough was 26. The first title is 25.5. So you are going to ensure that your second one should be like 25.4. Okay, or 25.3. That's really. So you repeat the same procedure as we did for this to do your second and to do your third title. So when you are done, you find the average of the values.
Okay, so this is basically how to do your first, your rough, your first. Okay, and of course you follow the same thing for your second and your third. Okay, so we'll look at how to find the average value. Then we'll now go straight into the main thing, which is calculation, and of course that is where the bulk of your work will be. Okay, so quickly, based on what you have seen so far, in calculating in doing your rough, in doing your first titration, I want you to just tell me something you have learned quickly on this. Yeah. Or if you have an addition that you want to state. Okay, we have a guest chemistry tutor around. Okay, so you want to say something? Okay, or Sean, do you want to say something you have learned from doing your rough and your first title? If your audio is not fine, you can just send me chat in the chat session. I will read it out. Okay. Yes, quickly, so that we can maximize time for calculation. Yes, Sean? Yes. Oh, I'm sure you're not, maybe you're having network issue. Okay, Sean? Yusuf, are you still there? Okay. Let me check. So we have seen how to do the rough. Okay, let me read your chat. Okay. Okay, that's brilliant, Sean. Okay, she said that you need to make sure you are reading from lower meniscus. That is very key, very important. Make sure you are reading from lower meniscus. Okay, that is very, very key and very, very important. Okay, very key and very, very important. Okay, so okay, now let's move on to how to find your average title word value. Then we'll now do calculation. Okay, so how do you find your average title value? Okay, so you have done your first, you have done your second, you have done your third titration. Now you want to get your title value, volume of acid used that you can use for your calculation.
Done the rough and the first title value, so you will repeat the same procedure as you did for your first title value to get your second title value and the third title value. Okay, now to calculate the volume of acid used, which you are going to use for your final calculation, you are going to find the average of the title. So now if you check your record, as you can see on the screen, you have your rough value, you have the first titer, you have the second titer, you have the third titer. So to find your average, you have to use only the first, the second, and the third titer value to calculate. So you are going to add them up. First titer value 25, second titer value 25.2, third titer value 25.3. So you add all the three together and divide by 3. So when you divide by 3, whatever value you get will be the average volume of acid used, which you now use to do your calculations that follows your question 1A, 1B, 1C. So the average titer value, you get it from your first titer, second titer, and third titer. Don't include your rough value.
Okay, so that's how to do your titer value. Okay, remember, the moment you finish your titration, the next thing would be the moment you finish your titration, the next thing will be recording your result and doing calculation. So please, this table is very important. You must note the volume of pipette you use. You must note the type of indicator that you use. Okay, and of course, you know the color change. Methyl orange changes from what? Changes from yellow. Okay, your methyl orange changes from yellow, okay, to what? To red. Okay, yellow to red. So when you are doing your titration, you know, methyl orange is yellow, okay, in base, okay, yellow in neutral, okay, and of course, orange red in what? In acid. So if it's becoming too red, dark red, that means you have excess acid added. Okay, so from yellow to red, that will be around orange. Okay, then that's when you stop your what? Your titration. Okay, it's very important that you note all that. Okay, now I will use this to reiterate again how to note your first and second and third titer. Let's assume that I started my titration from 0 May. Okay, that's where I started the titration from 0 May. Then I ran the acid into the base. Of course, you know your volume, your level of acid will be decreasing. So if for my first level of acid, I got 26, okay, that means in my table of result, it means in my table of result, I will go and write what? I started from 0, okay, 0. My table of result, now my final is 26. So I'm going to write 26. Please, I hope you are noting this. Okay, so now I want to do my second titer, and I've added like 26. I know that I don't have enough more, up to 26 more to add to my second word titration. So I need to refill my buret with more acid. So I refill my buret with more acid. So let's assume that I started from 0 again. Okay, you can start from 10, you can start from 15. Okay, so if I start from 0 again and I ran it and I got let's say 25.5, so I will go to my table. That's when you go to your table. I'll go to my table of result. Okay, then my initial here also is 0. Okay, I got 25.5, so I'm going to write 25.5, and I'll find the volume of acid used to be 25.5. Okay, so you repeat the procedure until you are done with your second and your third titration. And so when you get a table of result like this, then you're now going to use this table of result to calculate your titer value. Okay, so to calculate the final average volume of acid used, so we have started a calculation now, so you need to be very attentive to calculate the average volume of acid used. Then you will go to 20. You are going to add this plus this plus this. So you are using only your what? Your first, second, and third word titer value. So I'm going to add 25, okay, 25.5 plus 25.3 plus 25.2. Then I will divide by what? Divide by 3. So what value should we get? That should give us 70. 76, okay, over 3, and that will give you what? 25.33 me. This will be the volume of acid used. That will be the first thing that they will mark. That's the first thing that they will mark. That's the volume of acid what? Acid use. Okay? So that's basically how to do from working from titration to what? And this should not take you more than 15 minutes to do. Please, you need to also work with time. Now, let us dive straight into calculation. Good. So, needing your maximum attention now, let's dive straight into calculation. So, I will just give you sample, questions. Sample questions. Okay, these are sample questions, please. These are sample questions. Okay, so let's look at sample question one. Sample question one. But I'm pretty sure if you look at, I'll have 4 sample questions for you, but I'm pretty sure with those 4 sample questions, it's a done deal. Okay, it's a done deal. Okay, so sample question one. Good. So you could have a question like this given to you to solve. Okay, so let me be sure you are with me now. Hello, are you with me? Hello, are you with me? Okay, if you can send chat, let me know you can hear me. Okay, good. So if you are with us on the YouTube channel too, you can send your chat. That's fine. Okay, so it said a solution of triazonitrate 5 acid. Okay, that should be triazonitrate 5 acid. A solution of triazonitrate 5 acid of unknown concentration. A is a solution of triazonitrate 5 acid of unknown concentration. B is a solution containing 0.99 gram of what? Sodium hydroxide per 250 cm3. Okay, so that's the first statement there. Then they said put solution A into the buret and titrate 25 cm3 portion of B with A. Okay, so now using methyl orange as indicator, record the volume of your pipette, tabulate your buret readings, and calculate the average volume of acid used from your result and information given above. Okay, so the first thing that we're asked to do is to calculate the volume of acid used. So when you get questions like this, the first thing you are going to do is this table of result. This table of result is very well, very, very important. Please don't miss it out. This table of result is very key, very important. Okay, so the question says calculate the average volume of acid what? Acid used. So I'm using this as a demo, okay, titer value, okay, as a demo titer value. So we are assuming this is our titration result. We are assuming we have done the titration. This is the result that we got. So we'll write down volume of pipette used and indicator used. Indicator used is methyl orange. So this is the table I got from titration. Now I want to calculate my volume of acid use. Average volume of acid use. So my average volume of acid, my average volume of acid, okay, use will be equals to, so let's add it together. Don't forget, I said you are going to use your what? Your first, your second, and your what? Your third titration. So what's the value? Press your calculator too with me. Okay, 15.85, okay, plus 15.8, then plus what? 15.9. So we are going to divide the answer by what? By 3. So what value did you get? Yes, 15.8, 15.85. Okay, so I want to work with you so that we'll be on the same page. 15.85, okay, plus 15.8 plus 15.8 plus what? 15.9. Okay, so we got 47.55. So divide 47.55 by 3. So what do we get? Divide by 3, we get 15.85. 15.85. This is equal to 15, okay, 0.85 mil or centimeter cube, if you like. This is the first mark that you are going to be getting. Very important. 15.85 what mil. Okay, so we'll be using that for our calculation. 15.85 mil. Okay. If you have questions to ask, you can stop me and ask your question. Okay, you can stop me and ask your question, and I'll be so delighted to respond to your questions. Okay, so in carrying out your calculations for chemistry, you need to recall a few things. Okay, you need to recall a few things. Your moles. Okay, so you know what amount in mole is. Amount in mole is simply the amount of substance that contains the same number of elementary particles as can be found in carbon 1 mole of carbon 12 watt isotope of 12 gram of carbon 12 watt isotopes. Okay, so you need to also remember a few formulas in calculating in doing calculation that has to do with titration. Okay, for example, to calculate number of moles, okay, you know, to calculate, just to recall a few formulas with you. Okay, to calculate your number of moles is equal to concentration times what? Times volume in dm cube. Okay, that will give you the number of moles, okay, of acid or base in certain quantity of acid or what, or base. So multiply the concentration by what? By the volume given, divide by what? 1000, and you will get that. Okay, so so as we walk along the line, we'll be stating the required formula that is getting excited. Yeah, I'm getting so high, getting excited. Yeah, so concentration of solution B in grams per dm3. Okay, by now you should remember that concentration in grams per dm3 means what? Concentration in grams per dm3 is another name for what? For mass what? Concentration. That's another name for what? For mass concentration. Okay, very important that you record that. That's another name for what? For mass concentration. Okay, so when you say concentration in mole per dm3, what does that mean? Concentration in mole per dm3 simply means what? It simply means molar what? Molar concentration. Molar concentration. Okay, so we can combine these two units of these two terms, concentration terms, together in a formula that says that molar concentration, okay, molar concentration is equals to what? To mass concentration over what? Over molar mass. This formula is a joker, very, very, very important. Over molar what? Molar mass. This is a key formula. This is, yes, this is another formula here that is very important for you to what? For you to note. Okay, good. So let us proceed. Let's proceed. We are running against time, but let's move on gradually. Okay, so now concentration of solution B in grams per dm cube. Concentration of solution B in grams per dm cube. Now, concentration in grams per dm cube simply means the amount of a substance, okay, the mass of a solute that is dissolved in 1 dm cube, and 1 dm cube, okay, is equals to 1000 centimeter cube, or 1000 mil, or 1000 mil, 1000 centimeter cube, or what? Or 1000 mil. That is 1 dm cube. So concentration of solution B in grams per dm cube. Let's go back to the question. Okay, let's go back to the questions, and from the question we'll be able to see whether we have a clue to help us do this calculation. So going back to that, this is the question that we have. Now in the question, we're giving this. It says that solution B contains 0.999 grams of sodium hydroxide per 250 watt, 250 mil. Okay, I need to begin to think there. What do you think that clue will give us? Okay, what do you think that will give us? That's a clue. That's a clue that we need for this particular, for this particular work. That's a clue. 0.99 grams in what? Of sodium hydroxide in 250 mil. That in 250 mil, this simply means that if we have that in 250, so what are we going to find in 1000? Because concentration in grams per dm cube, okay, simply means mass concentration. And mass concentration means amount in solute dissolve, amount by mass of solute dissolved in 1000 mil of solution. Okay, but the question says that we have the question says we have 0.99 grams of sodium hydroxide, okay, in what? In 250 cm cube. So you ask yourself, in 250 cm cube is 0.999, and they are asking you how many will be in 1000. That is per dm cube. Per dm cube means per 1000. So in the question they told you it is 0.99 in 250. So how many do you think will be in 1000? How many? So you ask yourself, how many 250 can I get in 1004? So you just ask yourself and say, okay, if 0.99 gram of sodium hydroxide is in 250, then X gram will be in what? X gram will be in 1000 cm cube. So my X will be equals to what? My X will be equals to 1000 over 250 times what? 0.99. And this should give me what? Okay, let's do the calculation. That is 0.99 times what? Times 4. 0.99 times what? Times 4. And that gives me 3.9 what? 96. 3.9 what? 96 grams, okay, per dm cube. Grams per dm cube. This your unit is very important. Grams per what? Per dm cube. Grams per dm cube. So 3.96 grams per dm cube of sodium hydroxide. That is what we have. 3.96 gram per dm cube of sodium what? Hydroxide. That is exactly what we have there. Okay, so we have gotten that now. Then they're now asking us, question B says, calculate the concentration of solution B in moles per dm cube. Moles per dm cube is this molar what? Molar concentration. And so that means this formula will be very useful. So when you are doing your calculation, it's very important. Write your formula first, please, so that you can get your full marks. Okay, write your formula. So I'm going to write the formula for this particular to calculate the mole per dm cube. That is molar concentration. It simply means amount in moles of solute dissolved in 1000 mil or 1000 cm cube or 1 dm cube. Okay, so that is what I have. So I'll just say molar concentration. My molar, okay, molar concentration is equal to mass concentration over what? Over molar what? Molar mass. Okay, so ask yourself, what is the mass concentration we got here? That was what? 3.96. Okay, so but there is something that we need that we don't have yet, and that is the molar mass of what? Sodium hydroxide. We already know the mass concentration. We know the mass concentration, which is what we calculated in A, but we don't know the molar mass. We don't know the molar mass. So can we calculate the what? The molar mass. That's what we want to do now. We want to calculate the what? The molar mass. Okay, how do you calculate the molar mass of sodium hydroxide? Molar mass of sodium hydroxide is calculated by adding all the relative atomic what? Masses. So if you go back to the question, you will see here that they told you sodium is 23. Okay, from the question there, they told you sodium is 23, oxygen is 16, hydrogen is what? 1. Okay, so let's go back to this. Let's go back to this. Your sodium hydroxide. So this is what I'm saying. To calculate your molar mass of sodium hydroxide, you need this. Sodium is 23 grams. Okay, oxygen is 16 grams, hydrogen is 1 gram. By the time you add all these together, you're going to be having what? 40 grams per mole. Okay, that means this is the molar mass. This is called the molar mass of sodium what? Hydroxide. That is the molar mass of sodium hydroxide. So let's add the molar mass of sodium hydroxide. We got 40 grams, right? So now let's finish up this particular calculation. We got 40 grams for this, and here we got 3.96. Okay, 3.96 over 40. Okay, 3.96 over 40. So let's press our calculator and see what we'll get. Okay, 3.96 divided by 40 grams. Okay, that gives us 0.09. 0. What? 0.09. 0.09. So 0.09 is the what? Is the amount in moles of what? Of the base. So that gave us 0.09. Okay, yeah, I got 0.099. So that is moles per what? Per dmq. So this gives me the molar concentration. So I've been able to answer the first question here, and this is my answer. Okay, and the second question, this is my answer. Okay, so let's look at C. Let's look at C. C says concentration of solution A in moles per dmq. Concentration of solution A in moles per dmq. Now, this is getting deeper. We have calculated the concentration of your base. For your base, the concentration of B, which is sodium hydroxide, okay, we got 0.099 moles per dmq. So it means we know C, which is concentration for base, we know C. Then any other thing that we know for base, we know the volume of base that we use. That is 25 ml from your pipette. 25 ml. Okay, good. So now, but for your acid, which is solution A, we don't know the concentration of acid. So how can we get the concentration of the acid? That is the essence of titration. You are using something that you know to find something that you don't know. Okay, that is titration, called in general chemistry terms standardization. Okay, so concentration of solution A in mole per dmq. So we are going to use another important formula here, and that formula, okay, is this formula that says Na over Nb is equals to Ca, okay, Va over Cb Vb. Now, don't be perturbed. The formula, of course, you should be used to this formula. Okay, Na means the number of moles of acid in the stoichiometry, in the equation of reaction. There is going to be an equation of reaction. For every titration, there is an equation. So you must be able to write equation of reaction and balance it. So we have number of moles of acid. Nb means number of moles of base. Ca means concentration of acid. Va means volume of acid used, and that Va is your what? Is your titer value. Va is your titer value. I'm saying that again. Your Va, okay, is your titer value, which is the volume of acid you want to use. That's your Va. Okay. Ca is the concentration of acid. Concentration of what? Of acid, which we are looking for. Okay. Vb is the what? Is the volume of base used. That is Vb. Cb is the concentration of base, which we have calculated. So you can see here in this equation, in this formula, we are looking for, we don't know Ca. That's what we are looking for. Okay. But we know Va, titer value. We know Vb, volume of base used in the pipette, 25 ml. We know concentration of what? Of base, which is 0.0999. Now, how do we know the Na and Nb? That means you have to go and write the equation of the reaction. So let's write the equation of the reaction. Okay. Now, this reaction is between sodium hydroxide. Look at your question again. The reaction is between sodium hydroxide and what? Nitric acid. Okay. Sodium hydroxide and nitric what? Nitric acid. Okay, sodium hydroxide and nitric acid. Now, so you need to remember your formula for your sodium hydroxide and your formula for what, for nitric acid. Okay, so we have your formula for nitric acid and your formula for what, for sodium hydroxide. So let's write the formula for nitric acid and formula for sodium hydroxide, and write and balance the what, write equation for the reaction. So your sodium hydroxide, okay, will react with what, nitric acid, HNO3. So balance the equation. It's going to give you what, sodium nitrate. This is a very simple equation to balance. Very simple equation to balance. Okay, Na plus what, plus water. It's going to give you Na plus what, plus water. Okay, so now if you look at this reaction, we have 1 mole. It's balanced. This reaction is balanced. Equation is balanced. Okay, we have 1 mole of acid neutralizing 1 mole of what, of base. 1 mole of base neutralizing 1 mole of acid. This is your Nb. Nb is 1 and Na is what, 1. Okay, so how do we get this number of moles? It is the coefficient of this particular species, the coefficient of this nitric acid here, okay, and the coefficient of what, of this base here is 1 1. Since no value is written in front of it, it's 1 1. So that means that the ratio is ratio 1 to what, ratio 1 to 1. Okay, good, ratio 1 to 1. So Na is 1, Nb is what, is 1. So let's now look at the reaction proper. Let's look at the formula. Let's use that formula now to do our calculation. Okay, so let's use the formula to finish up. The formula says Na, okay, Na is equals to CAVA. So I'm going to take the formula Na over Nb is equals to CAVA over what, CBVB. Okay, so now it is 1 over 1 because Na is 1, Nb is 1, equals to what is the concentration of Ca of acid. That's what we are looking now for. Okay, concentration of solution A in moles per dm cube is what we're actually looking out for. Okay, so multiply by Va. Va is your titer value. So let's go back to our table. What's your titer value here? Our titer value is what? Is 15.85. 15 point what? 85. So let's go back. Titer value, which is your what do you call it? Your Va is 15.85. So we write 15 point what? 0.85 over, okay, over Cb. Cb is concentration of base, which is this 0.099 multiplied by Vb, which is the volume of what? The volume of base used, which is 25. So you don't need to divide by 1000 here because both your acid and your base have the same units. They will cancel out. Okay, so now let's make Ca the subject of the formula. From this equation, Ca will be equals to what? 0.099 times 25 over what? Over 15.85. Okay, so let's now divide. Let's divide. This is interesting. Okay, times 25 times 25. Okay, divide by what? 15.85. Okay, divide by 15.85. What do we get? 0.156. 0.156. You have 0.156. Okay, mole per what? Per dm cube. 0.156 mole per dm cube of what? Of acid. So you can see how we moved from a solution of known concentration, which is your base, okay, to a solution of acid whose concentration we don't know, but via calculation we're able to calculate the concentration of the acid there. Okay, so this is the concentration of our acid. Now they ask us to find question D. This is your question D. Question D says that we should calculate, for question D, it says that we should calculate the concentration in grams per dm cube of the acid. That means now we want to find the mass concentration of the acid. We want to find the mass concentration of the acid. So let's find the mass concentration of the acid. Okay, that's the question we are solving. Mass concentration of what? Of the acid. So how do you find the mass concentration of your acid? Remember the formula that connects. Okay, this formula is very important. Okay, the formula says molar concentration is equals to what? Mass what? Concentration over what? Over molar what? Over molar mass. Okay, so what is the molar concentration of acid that we just got now? That is the value we just got now. That is what? 0.156 moles per dm cube equals to what? Mass concentration. That's what we are looking at for. That's what they say you should find. Met you see grams per dm cube, it means mass concentration. So they ask us to find the mass concentration, which what we are looking at for. So let us just say mass what? Mass concentration over molar mass. Molar mass of sodium hydroxide is this 40 grams that we calculated here. 40 grams. So we are putting that 40 grams into this. So we have 40 what? 40 grams per what? Per mole. 40 grams per mole. So essentially, your mass concentration will be equal to what? 0.156 times 40. So that gives us what? Times 40. Okay, 0.156 times 40. So times 40, we are going to be getting 6.25. 6.25. So we have 6 point what? 0.25, okay, grams per what? Per dm cube. This is brilliant and wonderful. Okay, so that's how to use your titration result to actually tackle questions that will follow. So bulk of the marks that you get in your WAEC titration for question 1 is usually around what? Your calculation. Please, you need to get your calculations right. Follow this step. The formulas that you need are just those simple formula that I have used in this particular calculation. Okay, good. So let me get feedback from you. Okay, I'm going to be sending you these materials and sample questions. I have sample questions 2 for you. Okay, sample questions 2 for you to solve. Okay, I have sample question 3 for you to solve. I have sample question 4 for you to solve. Okay, so by the time you go through these sample questions, you would be fully ready for your exams. Okay, yeah, you'll be fully ready for your exams. Okay, so I will let you do the practice of these sample questions. Okay, then if we meet again in another session, okay, of this chemistry experience, then I'm going to hear from you. Then I'm going to do corrections to this sample question. So this is sample question 2. Okay, this is sample question 3. Okay, this is sample question 4, and this is sample question 4 for you to solve. Okay, by the time you go through all these 4 sample questions, I can bet you with you your A1 is so sure. Okay, yeah. Can I get feedback from you, Shion? Sean, are you there? Okay, good. Okay, so I hope this has been helpful. Okay, you
Yes,
can.
sir.
Okay, so let me know. Tell me what you've learned. Okay, tell me what you've learned. Do you understand this calculation? Do you understand the calculations? Okay, brilliant. She said yes. Okay, brilliant. Okay, so we have 7 more minutes to 12 or to 12 o'clock. Okay. Do you do you um do you want us to do sample question 2 together now? Do you want us to do sample question 2 together now? Okay. 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 Good. So this is okay. Yeah. Good. So for your I'm going to be doing the calculations. Okay. I'm going to do sample question 2, sample question 3, and sample question 4. I'm going to do the video of the solutions to the sample questions. Okay. And I'll be putting it on this on the Arid Online Academy YouTube channel. I will share it with you so that you can watch it. Okay. And compare it with your own calculations. Will that be fine? Okay. That'll be fine. Okay. And I'll be sending this material to you right away. Okay. The PDF of this material so you can see the question yourself too and be practicing it. Okay. Then you can check up the YouTube channel later on. Okay. You will see video of this. Okay. So I'll be sending you message for this is question 1. Okay. Question 2 will be on qualitative analysis, cation, anion test. Okay. So for that particular one, I'll send you a message on when we are going to meet online. Okay. To do that session. It could be this evening or tomorrow. Okay. Would that be fine? Okay, I'm saying that for the question 2, which is also a practical for qualitative analysis, cation and anion test. Okay, we'll be having a what they call it, a session tomorrow, mainly tomorrow. Okay, for that part, so that you can practice these ones today. You get that? Solve the questions that I will send to you too. Okay, you can do a screenshot of your calculation, send it to me. I can help you do corrections. But I'm going to be doing video of this particular calculation. I'll be putting it on the YouTube channel. You can check that up later. Okay. But basically, for the qualitative analysis, I'm going to be sending you the time we are going to be meeting on that tomorrow. Okay. Good. Okay. Yeah. Professor Akande, how are you? Yeah, thank you for joining us. Okay. Okay. So I'm going to send you the materials, the PDF material right away so you can practice all through evening. Okay. Yeah. I think we have done pretty well for this first session, right? Yes. Yeah. I know the internet the internet could be bad. The internet could be bad, but I think we've done pretty well for this particular one. Okay, so I will send you a message for when we are going to meet tomorrow for another session for qualitative analysis. Okay, I'm pretty sure you have had fantastic time learning and doing learning in this uh, particular session. Okay, if you have a question to ask me now, you can ask the question. You can ask your question. If you have a question to ask me, you can ask your questions now. Okay, any questions, please? Any questions? Any questions to ask? Okay. Okay. So, uh, Million, in the absence of any questions to ask, okay, I think this is a wonderful experience this morning. Okay, this is the chemistry experience with the inspirational Larry Abolaji. Okay, so I'm going to be catching you again in the next session. Stay tuned. Make sure you like, make sure you share, and make sure you subscribe to this YouTube channel for more videos that will lead you to your A1. Thank you for joining us. See you guys.